Welcome to JCon!
Thank you, Richard, and welcome everybody to JCon. And this was obviously the best introduction ever we had at JCon. Thanks, Richard. It's all about AI these days, right? And I saw these Terminator photos on these pitch conferences in San Jose, so I thought I have to jump in and use this story for my keynote. And all of these modern apps, it's all about data. And with AI, the amount of data will explode in the future now. And there are three really critical factors for all of these new applications. High performance, low data storage costs, and simple implementation. So imagine we have not enough performance for the Terminators. This would be bad for the machines, then we definitely will win the war against the machines. Or imagine we have enough Terminators, but the cloud costs are too high, so we can only run some Terminators, so this will not work. Or if it's too complicated to implement it. So I believe we need something different for the future for implementing AI applications faster, more simple. We need more performance, and we need lowest data storage costs in the cloud. And the great news with Java, this is absolutely possible. And at this point, I'm super happy to announce now that MicroStream is now Eclipse Store. It's now an open source, or it actually is an open source project for 2 years already, but it's now an Eclipse project, and we split the project in actually two Eclipse projects. One is Eclipse Serializer, and the other is Eclipse Store, and both are now available in version 1, milestone version 1, but it's almost the final release. It only depends on the internal process of the Eclipse Foundation, and we expect that we can launch the final release in hopefully some weeks now. And the functional principle of Eclipse Store should become a standard. So we will work on a new standard, founding a new working group, and similar to the JPA standard, we will create a standard for this functional principle. About myself, so my name is Markus. I am CEO and co-founder of MicroStream, and I work with Java teams since almost 1998. So we started with a web design project called Xpage, and then we developed a complete Java development environment, the XDev IDE. We open sourced the framework some years later, and then we migrated everything to Eclipse because Eclipse became more and more popular these days, and so we decided to switch over to Eclipse. Then we used Vaadin, and we developed a new JPA SQL query language. I talk about this because sometimes my talk, it seems like we do a little bit Hibernate bashing, but it's not the case. So it is very important for me to mention that we worked on the JBoss Hibernate tools for many years. We tried to improve and extend the tools. So we created JPA SQL to make Hibernate queries more simple. We improved the import-export functionality, so actually we really love the concept because it's the simplest way of storing data in a relational database. But then we started with something new because the Eclipse development environment was still too complicated for our users, building user interfaces was super easy, but as soon as we wanted to store data, it became very complex and effortful, and so we decided to develop something different, which is core Java-like, which is simple to implement and super fast, and this is what Eclipse Store is. So what actually are the challenges with data storage in Java? Of course, we all love Java, and it's because of its object-oriented, type-safe. We love clean code and POJOs, no dependencies, good testable code. So these things are super important for us. But when we talk about data storage, then sometimes we leave this way. So here is an example. When we use JPQL, for instance, then I very often see these SQL strings. What's about type safety? Probably not that important when we store data. If you want to use a type-safe query language, Java provides also type-safe query language, no problem. Then we have JPA Criteria API, for instance. It's type-safe, but effortful and ugly to read, so this is probably the reason why not many people use JPA Criteria API. And as soon as we want to use specific functions of a database, then probably we use native queries. Then we also have strings, so SQL strings. Not that great. What about microservices and data storage? So I believe relational databases and JPA fits great to monolithic architecture and to this paradigm. But with microservices, everything changes. So because now we should cut the monolithic application into numbers of single services. They should run in their own container and should run on a container platform. Everything should be small, should be micro. Every single service should be responsible for a specific use case. So great, we have great frameworks for that. Everything works great in Java. But as soon as we want to store data, then we still use the database servers, which are actually monolithic applications. So then we use a huge monolith. And there are further challenges, because with a programming language like Java, we are able to do everything. So we can build an ERP system, we can build a small service, we can run it on a mobile or embedded device. We can also do AI, no problem. So because we have all this data structure in Java, no problem. But the databases cannot. The databases, they provide their own data structure, and they are built for a specific use case. So probably it's not a good fit to use a time series database for complex data. And vice versa, if you have super complex data, probably you want to use a graph database instead of a time series database. So actually you should deal with multiple databases in a microservice architecture. this is effortful. Then there are also technical challenges deep inside, under the hood. For instance, when we build an application in Java, then everything is object-oriented. We use objects, of course. But with a relational database, it's not possible to store objects. This is, from the technical perspective, not possible. Because we have various impedance mismatches here. So the object model is much more granular. For instance, we cannot use inheritance in the relational model. And also, when we identify an object, we have internally the object IDs. This is not possible with the relational model. We need a synthetic key value, foreign key constraint here. And also searching in an object model is very easy. This is not that easy in a relational model. We have to use SQL. So there are a lot of differences in terms of the data types. So in Java we have around 8 primitive types, and PostgreSQL, for instance, has around 40 or even more data types. So this might be a problem. And it's similar with the new NoSQL databases. Now we have new databases. They all introduce their own data structure. For instance, JSON or XML, or it's a graph database. But all of these models are database-specific models. And even the old object-oriented databases, they had their own object model. It was not compatible with the Java object model. So in the end, we need something, we need a kind of like mapping between the application and the database. And we cannot use all functions of Java anymore. So we are very limited, so we have to use the functionality of the database, and we have to build the Java application around the database, no matter which database we use. So these problems are well known, and it's I believe we cannot solve it. So it's because they are incompatible. Who of you uses Hibernate? All right, yeah. And NoSQL databases? Okay. So obviously all these problems are solved, right? Otherwise we would not be able to store data. And of course it was solved. So with Hibernate we have a great framework. And the idea is we want to store objects. And we don't want to get in touch with the database anymore, so kind of like abstraction, storing objects. And with the NoSQL databases, we need a data conversion behind the scenes. And when we get data back from the database, the same again. So we have to generate objects through every single read and write. And this leads to very expensive latencies and increases the complexity. And this might be the reason why Hibernate sometimes is not that ultra fast. So we can solve this because we can add a cache. And with Hibernate, of course, we have a cache strategy. So just add second level cache, you can add a local cache. Everything is fine, but we can see the complexity increases more and more. Who of you develops distributed applications? Okay. So what about distributed applications and local cache? So if we change some data on one of these application nodes and we store data in a database, everything is fine because the node and the database are in sync. But the problem is all the other nodes and the database are not in sync. But no problem, we can solve this because now we can use a different cache strategy. You just put the cache in between the application and the database. And to avoid a single point of failure, we use a cache cluster. So this is distributed cache. Who uses such an architecture? All right, that's common. Great. If you have more load on the database, what we're doing is we use clustering on a database layer as well, and we use replication. Of course, this is common. But in reality, it's not enough. Oh my goodness, I very often visit customers and I see they use additional features for searching. Who uses Elasticsearch? Great solution, great company, very successful, but why? I was wondering, why are they so successful? Because the database specialists, they tell me the database is great. It's faster than your Java stuff. We don't need it. We just need PLSQL, that's it. Go away with your Java. Why? Why do they use Elasticsearch? Because if we have some more joins, probably the performance will not be that great. So let's use a search server in addition to that, which means then we have four cluster tiers. We need a lot of machines to run. And does it really make sense to use a distributed cache and saving memory? Memory is expensive, right? So which means in our application nodes, we should not use much memory. Please just use lambdas with 512 megabyte memory, because memory is expensive. Buy a distributed cache cluster, put tons of memory in it, it's a different layer. Don't care for that. Or put all of your memory in your database server. No problem. It's a different budget. So, and great point, because databases are very expensive in the cloud. And I saw all these business numbers. It's important for managers. So Gartner says 75% of all databases are still running in the cloud. Astonishing, but yeah, great. Why is a database as a service so expensive in the cloud? For instance, if you need 250 gigabyte PostgreSQL as a service at AWS on a small machine, we pay around $8,800 per year for one database node. Using only one node is not that great. It should be high available, it should be able to scale horizontally because we are in the cloud, and all of our services should scale. Why not scaling the database? Of course it should scale, so use 3 or 4 or 5 nodes and our price will double or triple. If you need 5, 6 database nodes, we pay around $50,000 per year for database as a service. That's really expensive. And companies run hundreds or even thousands of databases globally. So this is the reason why they all say, oh, our cloud costs, we run out of money, so they are skyrocketing. But we also have great news, and because the cloud providers, they provide cloud binary data storages like AWS S3. And actually they will build for storing just binary data, like photos, PDFs, data like that, or metadata, for instance. And if we buy 250 gigabyte at AWS, for instance, S3, we pay only $73 per year. Awesome. And you do not care for replication, for maintenance of your database. It's because they care for replication, uptime, for backups, data center replication. Everything is provided by the cloud provider. So I'm not paid by AWS, which means you can have this service at all cloud providers, mostly they call this cloud blob store or cloud object storage. Also in Azure Cloud, Google Cloud, IBM Cloud, Oracle Cloud. Forget something? What about Java? I'm a Java fan since I'm working with Java and working with my Java teams, of course, and I was wondering why don't we use the power of Java? And because we have a JIT compiler. So when I started with Java, then I heard very often these phrases, oh, Java is so slow and C is faster. And now we have the great JIT compiler. It accelerates your application and it's executed super fast, and everything that is executed in memory is really fast. So I grew up with assembler, and so it was normal that your instructions were executed in nanoseconds. Or if you have an algorithm that should be executed in microseconds, everything should be executed in microseconds. When we talk about the performance of a database, we talk about milliseconds. And this is factor 1,000. So Java is a factor 1,000 faster than a comparable search or filtering in a database. So why not using the performance and power of Java? And another great advantage, we have a great data structure. I mentioned that with microservices, we should use multiple databases, right, for multiple different use cases. In Java, we can use objects and our data structures like collections for all use cases. So we do not think about, oh, should we use a relational model in Java? Should we use JSON? Should we use a key value structure when we do something in memory? No, we do not care. We just use Java. And we can use all data structure, all kind of data, and this is the reason why we are not limited to a specific use case. A database is always limited to a specific use case. Please do not use a time series database for a use case where you actually should use a graph database. In Java, we do not care. So we have object graphs in memory, everything is fast, and Java provides a great query language with Java Streams API. You can search object graphs in memory. Who uses Java Streams API already? Yeah, right. So check it out. So push tons of data in your memory, build a complex model, search the object graph. It will take microseconds. 1,000x faster than a comparable JPA query. The only thing missing in Java, this is so crazy actually, we can do everything. We cannot store data. Impossible. Yeah, it's because we have the databases, so why not using a database? It's because it's built for storing data. What are you talking about? It seems obviously, but on the other hand, it should be obviously to store data with a programming language. And it's possible, of course. So a lot of Java developers do it already. And there, 2 weeks ago or 3 weeks ago at JCon Slovenia, I met a guy from a banking company, and he said, we built such a system. So everything is executed in memory. It's super fast, low latency, millions of instructions per second. But we have to build this for our own. It's a specific use case, and we needed the performance, and this is the reason why we built it. And the functional principle is called system prevalence, and the functional principle is simple. Keep everything in memory, use your programming language, and create a snapshot when you need persistence. That's actually the functional principle. And your architecture gets super simple. So when I tell you about this functional principle, you might think this is not really great. But you can read about Martin Fowler and describes such a system. Who knows Martin Fowler? Of course, yeah, read it and then you're convinced. But there are also challenges with the functional principle, of course. This might be the reason why it's not that popular these days. And with Eclipse Store, now we have solved all of these problems. Almost all problems. So you cannot save all problems, of course, but most of them, they are solved. And then we get a really great solution for Java. And this is actually what Eclipse Store is. And in a nutshell, so Eclipse Store is similar to Hibernate, a persistence layer. We call it a micro-persistence because it's lightweight, easy to implement, it's micro. And for microservices, it runs in the same JVM process as your application or your microservice. And it enables you to store any kind of object, any kind of object graph, no matter which structure, no matter which complexity it has. You can use circular references, inheritance, build whatever it's possible in Java, and Eclipse Store will be able to store it persistently on disk in a binary format. And we use the Eclipse serializer for creating these binary files. We do not use the Java serialization because it's limited in terms of the structure and the performance, and it's insecure. Eclipse serializer is highly secure. It enables you to deal with any complexity, and so we use the Eclipse serializer. Vice versa, the framework allows you to load, similar to Hibernate, individual subgraphs. You can load the entire system state, but mostly you will just loads individual subgraphs and loads the object reference into the memory, and your object graph in memory gets updated automatically. All I/O operations are transaction safe, so it's combined with transactions. And you can use now the cloud object storages for persisting your data and save 99 or 98%, 89% of cloud data storage costs. You can use almost all storages that are able to store binaries. So you can also write your data directly on a persistent volume. It's also possible to use a database if you like to use a database for. It's because databases can also store binaries. And it's open source, of course. It's under the EPL license, of course, and it's not limited. So we have open sourced all features. It's well integrated with Project Helidon, which is one of the most popular frameworks for writing microservices these days. And they were the first implemented microstream, which is now Eclipse Store. And also it's well integrated with Micronaut. And we have integrations now for other frameworks. You can also use it with Spring Boot or Quarkus. So how does it work? Here is our architecture again, and let's have a look inside a database. Here we can see a database server. We have, at the bottom, we have storage. Of course, we need storage. But we have also a database management system, and this is the reason why we need a server. We need a machine, and we have RAM. We need a lot of memory. So, because the database also uses caching, not to, or to avoid access to the disk because it's slow. So put a lot of memory in your database, it will be faster, of course. And we have application business logic, stored procedures and stored functions. And who of you uses stored procedures and stored functions? Not that much, but some. Yeah, it's because in Java we do not need it actually. So we decide we do not use the database stuff. And with Eclipse Store, we also believe we do not use these kind of things over database server. We have everything in Java. So, and we now replace Hibernate or any other mapping or data conversion, like JSON conversion, we replace it with Eclipse Store, with the new persistence library. Then we keep data in memory, and we just keep data in memory, just the data we need. So we don't need the entire system state in memory. We don't need the entire database in memory. To just keep data in memory, you really need immediately. So then you can also run small RAM machines. It also works with Lambda. But the more memory you have, the better it is. So it is already memory, which means we don't need a cache. We don't need a local cache anymore. And we don't need a database system, database management anymore. So because the application logic cares for everything, concurrency is managed by Java. We have all of these functions. We don't need store procedures, we have Java. So the only thing we keep is storage. And our architecture gets really simple. And we have other talks here at JCon. We talk about the performance, and we can see performance demos. Let's have a look on how this works with distributed applications. Back to our architecture of an enterprise Java application. So we replace the Hibernate application nodes with our Eclipse Store nodes. And we assume we don't need that much services or nodes because they are much faster. So probably we just only need 2 to replace 10 Hibernate nodes. This is only expectation. You should check this out. Then we are able to replicate the object graph through hundreds or even 1,000 JVMs with Eclipse Store cluster. They are already in memory, which means we don't need a distributed cache anymore, because we use the object graph in memory as an in-memory database. It can be replicated, so it is working just like a cache actually. So we can skip the cache cluster. We just keep storage. We just need object storage like AWS S3, so we can replace the database cluster and we can eliminate the caching cluster. So this is the final architecture. Super slim and super easy to use, and core Java only. No specific database stuff anymore. Okay, here's a comparison. It's obvious. So only one cluster instead of 3 or 4 clusters. You can use Lucene, then you don't need a search server anymore, perhaps. And you can also run stateless functions, for instance, and call your Eclipse Store cluster via REST, for instance. Then you can also build your application nodes or your application logic or your serverless functions with other programming languages like Python. I guess you all love it. Who uses Python? Oh, no. Oh, okay. It's a Java conference, but Python is very popular. Use Jython. Yeah, it's possible. So, and here is a list of some storages that are supported. So you can use also databases, cloud storages. It runs wherever Java runs. So the only requirement is Java version 8. You can use it with all JVM languages, and it also runs on Android. So who of you builds Android apps? Not that much. So, and it's the same at the DroidCon conference. When next month we are at DroidCon. I ask who of you builds server-side applications? Nobody cares. So here is the big picture. So we hopefully will be able to launch the standard process this year. It depends on the internal processes of the Eclipse Foundation, and then Eclipse Store should become the reference implementation for the standard. And on top of that, we provide a cluster solution. and a managed cloud for that, because it's still challenging to implement a cluster environment. You have to deal with Kubernetes, and this is complicated stuff. And with the managed cloud, it's super easy. Just create your cluster with some mouse clicks. Here we have some more components. It's not just serialization. So Eclipse Store comes with a lot of further components, and very important is the legacy type mapping process, and it allows you to change your classes anytime. So don't care for schema changes. This is super easy with Eclipse Store. Just change your classes, don't care for everything. It can be solved by the framework through runtime. And if you add fields, remove fields, if you rename fields, everything can be solved by the framework behind the scenes. If you have more complex cases, you can define a legacy type mapping, and the framework will care for these schema changes. Everything is done through runtime. It provides you REST interface. You get access to your storage data, storage browser where you can browse through your storage data, backups. You also have native backups. There is a garbage collector because Eclipse Store stores everything appended to disk. It's similar then to event sourcing, but we do not store the event. We store really the changes of the state, but it's also stored appended to disk. We never overwrite data like a relational database. So it's always stored appended, and you can configure if you want to keep the older object versions, or you want to let the garbage collector remove the older objects from the storage. There are also challenges with Eclipse Store, of course. It's a paradigm shift in database programming. So now on the left side you can see the database server paradigm, and now we have an in-memory database paradigm. So everything is in memory, everything is executed in memory, everything is done by Java, core Java features. There are no requirements to your classes, no interface to implement, so just POJOs. And yeah, so think about this is your in-memory database. You cannot store and you cannot search on a different server anymore. You cannot search on the storage because it's your hard disk drive. So this is the paradigm shift. Good news, you don't have to load the entire database in a database. And the initial functional principle of system prevalence says, yeah, you have to load your entire database in the memory. With Eclipse Store, you don't have to load your entire database. Just load data into a memory you really need. Just the hot data. If you have enough memory, yeah, you can load your entire database in a memory. Then it's everything executed in microseconds, and because of the JIT compiler, sometimes really in nanoseconds. But don't build a Terminator, right? So that's evil. Challenges, it's built for Java developers. It's a paradigm shift in database programming, so we have to rethink database programming. So it's not built for DBAs. Obviously, they do not like it. So yeah, but it's a different approach, and we do not say it's the best approach for everything. So if you're a Java developer, if you like it, use it. If you don't like it, use your relational database. You have Hibernate. Everything is provided by Java. That's great. And with MicroStream, we will, or with Eclipse Store, we will have a great benefit because of the Java ecosystem. Now with virtual threads, your Java application will be faster, will be accelerated by the JVM. And you build a database application by using Eclipse Store, you update your Java version, and it will get faster, a lot faster, because your JVM will be faster. That's great. So which means if you have customers and you want to make your customers happy, just update your JVM, and you can provide an update. You can say, yeah, we worked on this, and now it's 20% faster. Wow, that's great, great news. So, but you have to use, you have to buy a support contract by us. That's great. Yeah, and there's no SQL support, obviously. It's we believe it is possible, by the way, and we are do little research on this. But currently, there's no SQL support. We have Java Streams API. All right, and how it works, we have a further session at the JCon conference where we jump into deep, where you can see the code, how easy it is, and of course we have performance demos, and we have great people at the booth, at the Eclipse Store booth. So we have pretty new t-shirts. You can get a t-shirt at the Eclipse Store booth, sponsored by MicroStream. If you have any questions, we have the people who write the code at the booth, ask the questions and check it out. And I wish you an awesome JCon conference and awesome 3 days. Enroll for the courses. Richard said they are free because I asked him. Yeah. Have a great JCon. Thank you so much.